Hello YouTube and welcome back. We are solving one last question from the binary section of the list of blind 75 LeetCode questions. Today we're going to look at reversing bits. We're looking at problem 190. The question asks us this: reverse bits of a given 32-bit unsigned integer. Note, in some language such as Java, there's no unsigned integer type. In this case, both input and output will be given as a signed integer type. They should not affect your implementation, as the integer's internal binary representation is the same whether it's signed or unsigned. In Java, the compiler represents the signed integers using 2's complement notation. Therefore, in example 2, as we'll see below, the input represents the signed integer -3. Let's scroll down and take a look at our examples. We have this random, really high integer that I have no idea what it is, and the output we're given is this number. And of course, if we take a closer examination, we can see that it goes 0, 0, 1, 1, 1, and we can look right here, it says 0, 0, 1, 1, 1, so we're just reversing the bits. And example 2 follows exactly the same. Every single bit is reversed, except for this one in the 2 position, and we see right here that we've also got a 0 in the expected place when we reverse the number. So let's take a look at how we can solve this. Well, we just want to write return integer.reverse n, and let's submit it. And we're done. Of course, I'm only joking. Please don't do this in an interview, although it's really good for situations like code golf when you're trying to do things with as less code as possible. But I guarantee that if someone's asking you this question, whether in an interview setting or in another situation where you're just trying to show your understanding of algorithms, this is probably not going to be what you want to write. So let's remove that. And let's have a think about how we can solve this question using bitwise functionality. So let's go ahead and draw up an example. I'm just going to start mashing on my keyboard right now. So we have this random number and we just want to reverse it. So what we can do if we just use a bitwise method is take a look bit by bit and see if we have a 0 or a 1, and then we'll just want to have a results integer, and we're going to keep adding that 0 or 1 to what we have, and then do a little bit of bit shifting in between. So let's just have a think through an algorithm. So what we know is that we have a 32-bit integer. So it would help if we had a for loop, and we'll just loop from 0 to 32. And we'll keep a running result integer. We'll just AND n with 1 to check what this last bit is, and then continue to add it to the result. And then we just want to bit shift n down. That means we'll just get rid of this last bit, and then continue on, just checking the next bit against 1. We'll AND it together with 1, and then we'll see that we have a 1, so we'll add 1 to our result, and then bit shift n down again. And we'll just continue on until we've got every single bit. So let's maybe take a look at a smaller example. Let's just do 0101, which actually is the binary representation for 5. So right now we have n equals to 5, and let's keep track of a result. So we have result equal to 0 for now. Let's write out the binary representation for this. This is going to be 0000. And with 32 bits, it's obviously going to be a lot more zeros. The binary representation for 5 right now is 00, all those zeros, and 0101. So then let's add in those extra zeros into 5. And let's take a look at this first bit. So what we want to do is take result and add n ANDed with 1. So what that means is we take n, which right now is 5, and let's AND it with 1. And we come out with a 1, right? So then that makes the result actually equal to 1 right now. So let's go ahead and change that binary representation. And then we want to bit shift n down by 1 place. So for simplicity, let's just remove that 1 and add in an extra 0 at the top. And then we want to bit shift the result up a place. So let's remove that 0 and then add an extra 0 there. So then let's reevaluate both n and result. So this is actually now equal to 2, and then result is also equal to 2. So then looping through again, we have result equals to n and 1. So let's take n, right now is 2. Let's reassess this one. And we're just going to AND it to 1. And of course, that's going to equal 0 because we don't have a 1 in the same place anywhere. So adding 0 to the result, we're still left with 2. And we're going to do our bit shifting again. So we'll bit shift n down a position. And we'll shift the result up a position. So let's reevaluate. N now equals to 1 and the result equals to 4. So one more time for our example's sake, we're going to do result equals to n and 1. So n now equals to 1 and 1 with 1 equals 1. And let's go ahead and add that to the current result, which is 4. We'll add 4 plus 1 equals 5. And let's represent that in binary notation, 0, 1, 0, 1. And then let's do a bit shift again. So we're going to bit shift 1 down, and we're going to bit shift result up. And as you can see now, we're only left with zeros in n. So there's really nothing else to do but to continue on. The algorithm will continue to add all of these remaining zeros, and we'd eventually be left with this massive number, which is actually just our original number, 0101, just in reverse order. So hopefully that makes sense. Let's go ahead and write the implementation. So we'll just want to start off with int result equals 0. We'll want to loop for int I equals 0 while I is less than 32, and we'll increment I every single time we pass through. And we'll say the result plus equals to n and 1. And then let's bit shift n down by 1 place. And remember, for this, we're dealing with unsigned integers, so we have to do the unsigned shift. And then finally, we have one more check that we need to do. We need to check to see if we're looking at that last bit in the 32-bit integer. If we're not, we can do the shift, but if we are, then we don't want to do the shift because that's going to leave us with an incorrect answer. So we'll just do if I is still less than 31, and if it is, we'll go ahead and bit shift that result. And then finally, when we've broken out of that for loop, we'll just return the result and we should be left with our answer. Let's go ahead and submit that just to show that it works. And that's great. So kind of simple in theory, but writing the code out might be a little bit tricky. So go ahead and practice this a couple of times. And we've reached the end of our binary section of the Blind 75 list of LeetCode questions. So if you're enjoying the series, I just ask once again if you could give a like on the video and hit that subscribe button. I really appreciate it. And then I'll see you tomorrow for another question in a brand new section.